Thank you for outlining the Penn State SMIC's value proposition for SESMI members. Next, we'll hear from Ragu Athinarayanan about the Purdue University SMIC.
The title of our talk is How We Are Deploying a New Smart Manufacturing Innovation Center to Accelerate and Democratize AI Adoption in Smart Manufacturing. Our first objective of this new SMIC is on how we can leverage the Smart Manufacturing Innovation Platform to lower the barrier for adoption of AI in industries, and also to provide shop floor friendly methodologies for non-experts to deploy AI solutions across different manufacturing applications. Our second objective of the SMIC is we are going to be showcasing 2 test beds and 1 exemplar to demonstrate the benefits of AI-powered solutions in manufacturing. Our 2 test beds are, one, a smart foundry at Purdue University. The second is a digital machining test bed at University of North Florida. And the third is a exemplar at West Virginia University, which is a digital supply network exemplar. The motivation behind our choice of these test beds and exemplar are, well, we all are aware of the fact that castings and machining combined constitute about 90% of all durable goods and industries in the U.S. Also, we are all aware of the fact that supply chain today is very complex and it's a multi-stage process, and not to mention they today lack resiliency and are very susceptible to failures and also to disruptions. Our third objective of this new SMIC is to host outreach events so that we can educate the manufacturing public so they can develop a better understanding of the value of the SMIC and also the Smart Manufacturing Innovation Platform that is hosted by SESMI, and also to showcase to them the benefits of AI and ML and how it can be used to support value creation and to improve manufacturing business outcomes. Here are a list of our partners, and besides the 3 universities, which is the Purdue University, West Virginia University, and the University of North Florida, this is where we are hosting the test beds, as you can see, and also where the majority of the research work is going to be happening with respect to this project. Microsoft is also a partner on this project. They will be providing access to their AI and ML technology expertise and also to their services in a very vendor-agnostic manner. Microsoft will also be providing access to their nationwide network of Microsoft Technology Centers to host events, provide demos, and also to offer training sessions on activities associated with the SMIC. We also have partners, industry partners, Caterpillar and Festo, and they are providing physical infrastructure for the test bed and also the exemplar at Purdue and West Virginia University. This is our SMIC team. We have a total of 6 of us currently, and we'll be adding more in the near future. We have Dr. Gokhan May, who is an assistant professor at the University of North Florida. He is also on the editorial board of the World Manufacturing Forum. His major research field is in the area of data-driven, smart, and sustainable manufacturing, including industrial energy efficiency, zero-defect manufacturing, and predictive maintenance. We have Dr. Thorsten Wust. He is the Associate Professor of Industrial Management and Systems Engineering at West Virginia University, and he is also the Director of the West Virginia University Smart Manufacturing Lab. We have Dr. Martin June. He is an Associate Professor in Mechanical Engineering at Purdue University with expertise in digital twins and AI applications in manufacturing. We also have Dr. Sungja Cho. He is a researcher with our group at Purdue University, and his expertise is in predictive maintenance, semantic technologies, and AI applications in manufacturing optimization. Not on our call today is Dr. Walid Ali. He is our counterpart with Microsoft, and he's also the Director of Artificial Intelligence at Microsoft. And of course, myself, I'm a professor at Purdue University and also serving as the PI of this project. Next, I would like to hand it over to Dr. Martin June, who will provide you the technical strategies and the processes we are using with this mic.
The strategy we're going to have is to find the physical assets at the testbeds and the exemplar. So from the physical assets within the physical world, we're going to find out and create machine profiles, which is a data model for the physical assets, and then create digital twins based on the profiles that we have developed in the cyber world. These digital twins will be augmented by artificial intelligence and machine learning, so that digital twins can become more intelligent. So with digital twins becoming more intelligent, the autonomous operations can become possible with these digital twins. So we will augment these digital twins with artificial intelligence and machine learning in order to develop AI-powered digital twin models. So this diagram shows the schematic of the AI-powered digital twins. So we have a smart manufacturing innovation platform, and it will be interfaced with physical assets at Purdue University, University of North Florida, and West Virginia University. So we will create smart manufacturing profiles, which are the data models for those physical assets. And this will be uploaded to smart manufacturing innovation platform. And using the data models, we have information or a base model to develop digital twins for the physical assets we have. So what we will do is we will create and develop AI-powered digital twins. And these AI-powered digital twins will be put into a smart manufacturing marketplace. And then apps and solutions can be created so that they can be used for plug-and-play style industry solutions. So what are the benefits of AI-powered digital twins? So with the smart manufacturing machine profiles as the data models, and the data that we get from those machines through digital twins as well, we will have great transparency. With this transparency, we will have a much better idea about product life cycle, and then we'll have a history of data throughout their use, product life cycle, as well as use of machines. So when you have all this history of data and so on, we will have much better flexibility to be able to optimize the production system, or if there is any incidences or anomalies or changes, we'll be able to react to those anomalies and changes through real-time data analysis and so on.
This is the Smart Foundry we were talking about that we are going to be hosting at Purdue University, funding we received from Caterpillar.
So here you see the University of North Florida Digital Machining Testbed. So here we will showcase the benefits of AI applications for zero-defect manufacturing. And in this testbed, what we will do is we will install sensors on our machines and illustrate that a precise prediction of product quality can be done by using data from these sensor signals. And SMIC, Smart Manufacturing Innovation Platform, will be leveraged by establishing connectivity with our manufacturing assets, and AI models will be integrated accordingly.
This is the exemplar that we host at West Virginia University in the Smart Manufacturing Lab. And what this exemplar brings to the SMIC to augment the already established facilities at UNF and Purdue is the multi-stage nature of our CPE lab that we have available in our facilities. That features 8 different processes, and we plan to connect that to our digital twin models, including the pallet transfer system, which is sensorized and allows location of all the different products that are in the production system, hence the supply chain, supply network perspective here. We see our SMIC not just as a SMIC for that one year or 16 months that it's initially planned for, but as a foundation for continuous growth and continuous engagement with our stakeholders and constituents. In that sense, our future work that we plan beyond establishing the SMIC is to incorporate collaborations with others, such as machine builders, system integrators, product vendors, to help them help us to grow our portfolio of AI-powered digital twins, and therefore help us to engage with more manufacturers locally and nationally to explore additional applications for our solution. A key to our work with our constituents is, of course, outreach and engagement. Henceforth, we plan to work with manufacturers, again, regionally and nationally. In doing so, we will host outreach events at all 3 locations, and in addition to Microsoft's MTCs. We will leverage our partners at the NIST MEP institutes at Purdue and West Virginia, which have very good relations with small and medium-sized manufacturers, but also bigger partners within our region. With Microsoft being a partner in our consortium, we have access to their extensive network of MTC centers, which we also plan to leverage to our advantage and to get the word out of the work we're doing. By developing that diverse portfolio of SM profiles, we hope to really reach a variety of different manufacturing domains. That's it from our side. Thank you so much. If there's any questions, we're here to answer them all. Thank you.